Hi everyone, thanks for coming. I know the food is tempting, but hopefully I'll bring about something interesting. So, welcome to the art of persistence lurking behind the browser. This talk came about from a red team assessment that we have done, and I intend to go about it from a narrative approach, where I'll go through the decision we make along this assessment as well, and rationalize the decision we make. Hopefully, from that perspective, you'll be able to understand why we make certain decisions a certain way, and hopefully you will make the same conclusion as us as well. All right, agenda. I'll first start off with introducing myself. Don't worry, it'll be quick because I'm not that interesting. Then we have the inspiration of this project. So what's the context of what started this? Thereabout, we'll go through what browser helper object is, what BHO is, the development as well as the considerations. And thereafter, we'll go through the detections as well as the artifacts that is on the browser helper object. All right. So just a quick shout out for NWPRA. They have this opportunity to do this assessment, and we have been doing red team, blue team, purple team, and all kinds of colors, whether it's AS, CC, BEST for a while. And I've learned a lot from this bunch of very smart people. Yep. Who am I? I'm a security consultant at NWPRA, so I had to break things that break things. Kind of ironic, oxymoronic, but yeah. I'm a full-time security consultant and full-time developer and sysadmin as well. What this means is, as I do assessment, as I test something, I like to think from the perspective of the people who are developing it, or the people who are designing the systems. And of course, everyone likes to take shortcut. What I love to do is to catch people doing all this shortcut. Yeah. So I also like to do development and maintain a small kind of home lab for a hobby. And the most important question, Vim versus Emacs. I'm Vim. Yeah. Woohoo. No supporter. All right. All right. Enough about boring me. I'll start off with the presentation order. So once upon a time, in a land far, far away, okay, Singapore is kind of small, 50 kilometers wide, but once upon a time, we are doing a targeted attack simulation for one of our clients in the region. So I know this term has been kind of thrown around in the industry as an industry jargon for a little while, but for us, what we mean by targeted attack simulation is we are robbing a bank. So it means we are stealing money, we are trying to make swift transactions, we're trying to steal customer data. So it's a full end-to-end execution in life, meaning it's a real production system. Real attackers don't care about how they do it, what format they go by, so why should we? Our goal is to steal money. Of course, it doesn't matter how we do it as long as we do it in an agreed manner, but we steal money, we steal data, and that is the goal of our assessment. So just to give you guys a status update, as I mentioned, this is a narrative format. Where are we currently at? We have completed reconnaissance of the target. We know what security system they are running. We know what technology they've implemented. We know who are working in the organization. And from this information, we know that they're running Microsoft Office. We have email address from a few of the people, and we know we're able to spoof email and be able to send phishing email over to the target. Right now, in the exploitation phase, we have managed to gotten an initial compromise through phishing email. We have managed to get in-memory payloads running through Microsoft Office macros. So from here we are in. We thought, all right, things is going to be smooth sailing from now on. This is where we went into persistence. Persistence is important because we have done all this effort to get an initial compromise. But what happens when end user turn off their laptops or desktop? Our payloads will then be shut down as well. So it's important that as the machines start up again, our payloads will be able to run again, and we'll be able to continue our exploitation. And that is where we have an issue. So interestingly, we have, as I was saying, we have in-memory payload, and we have laterally moved into the endpoint. We have managed to get around. And we have outbound network access via authenticated HTTP proxy. But what was happening is that persistent mechanisms were working 1 out of 10 times. So we kind of know something was blocking us, but was terrible at its job anyway. So it kind of worked 1 out of 10 times, and we were able to get in-memory payload. So we started troubleshooting. So we started to think maybe it's me, right? I'm the small, it could be a layer problem, user problem. So we tried different methods, like going through registry keys, going through scheduled tasks, and we're trying different methods, whether it could be EXE or DLL, that is not able to run as a stored payload. But these weren't the problems. We were not able to, So next we tried, maybe it's a layer 3 problem, a network problem. So we started to play around, but the interesting part was our in-memory payload worked, and they were communicating back to us successfully. So it's unlikely to be a layer 3 problem. So we started to link all of these troubleshooting together, and what came to us is that we know for sure is that stored payloads were not working reliably, and we now know we have 2 goals. First goal is to, so stored payloads were not working reliably, and it points to an EPP in place that were preventing it from working reliably. So we suspect that the next-gen AV has implemented some kind of application whitelisting. It is likely not a signature because our payloads were not signatured. So what we suspect is that there is some kind of limited application whitelisting. Only certain application is able to execute or is able to make outbound network calls, and that's why we're not getting callback from our stored payloads. So we started. So now we know there's 2 goals. First, we need to make sure that whatever stored payload we put in there, it has to work either by getting the whitelist or leveraging a whitelisted application. And 2, to make sure that it's able to get outbound network call. So with these goals in mind, we started to consider a few options to make sure that these 2 goals work. The first option we considered was to build a cradle to inject our payload straight into a whitelisted application. You could essentially find out which process it's in the whitelist and inject a memory page within the application so that we can inject a shellcode into there and able to leech off using the application to make it, to load our payload into. The advantage of this is we can leech off a whitelisted application, but the disadvantage of it is it's very suspicious. We're injecting our payload into an application, into a process, and this is highly suspicious for a defender. The next option we considered was to utilize existing known application that is able to execute code, for example, like macros. So in our reconnaissance, as well as we all know in the corporate environment, many workstations actually run Microsoft Office. And within Microsoft Office, we are able to use macros or perhaps word add-ins or templates that whenever Microsoft Office is launched, our payload will be able to be loaded as well. This technique is actually covered quite intensively previously by our labs in a blog post that you can read up for yourself as well. Well, the advantage is it works very well in a corporate environment. We know it works, it is very well known, but the disadvantage is also that it is very well known. It is easily caught, and it will raise a suspicious alarm for the defenders. Last technique we consider is to identify an application that is regularly used that is able to load additional code into. We can put our custom code into there and to be able to load our code payload through this application. The advantage of it is it's less well known, it's more customized, it is less likely to be detected. The disadvantage of it is that it requires prerequisites in that this application needs to be whitelisted and to be able to make network outbound call and is able to load the payload that we want in our way. So ultimately, once we know that we have to resolve these 2 goals, we could consider many options. And this is where we start to weigh the options. And as we start to weigh the options, we realize that every workstation we have seen is using Internet Explorer. So the advantage of Internet Explorer is that it requires outbound access for legitimate usage. So as you browse the web, as you visit a web app that is by your company, or you are using web app, essentially people need to surf the web anyway. It's generating many network logs. And within this network log, whatever our C2 communication is, will be hidden in these network logs as well. So it allows us to hide ourselves from all these network logs. And additionally, it utilizes the domain context to authenticate to the outbound proxy. So the organization that we were targeting is using outbound proxy, but it doesn't matter because we don't need to care about authentication because Internet Explorer needs the outbound proxy to connect to the internet anyway. So we don't have to worry about that. So this definitely is something convenient and useful for us amongst our choices that we're considering. And this is where we come into browser helper object. It kind of sounds complicated. You may not have heard of it, but I'm pretty sure many of us have seen it in this room. So sometimes when your parents say the internet is slow, you open Internet Explorer and you realize, hey, there's multiple toolbars. Well, browser helper object, it's a way for Internet Explorer to extend its capabilities, essentially like extensions or plugins. What it does, it requires a DLL to be loaded within Internet Explorer, and advantage of this as well is it's a DLL. So if you can, it's a binary or it's a .NET framework. So essentially anything that you code within the DLL would be able to, you will be able to get all the functions you get as you code in the DLL. It's also a standard functionality, so it's unlikely to trigger a use case for EDR. It also, sorry, my bad. Sorry. Yeah, it also has full access to the HTML. So it has access to the full HTML as well as the DOM of the page that you are visiting. This means that if you are surfing any web app, for example, you'll be able to see everything there. And if you are visiting any web app that contains secrets that we want to obtain, we'll be able to easily exfiltrate them as well through Internet Explorer. And essentially, it sees everything you see. So from here, we know this is what we need. We intend to build a payload using Internet Explorer for us to persist, and thereafter, using Internet Explorer BHO, we will then extend it from the BHO as a persistent tool to load a fully featured payload such as Cobalt Strike. So as I mentioned, it loads as a DLL. So I'll go through how Internet Explorer extends its capability through the DLL. So first, Internet Explorer would enumerate a registry subkey. If you're not able to see, it's a browser helper objects registry subkey that it will enumerate for the CLS ID that is registered to be a BHO. Thereafter, Internet Explorer will enumerate the CLS ID from the classes root subkey to find a COM object as well as a COM object DLL file so that it is able to load the DLL, load the library and run it within Internet Explorer context. So one thing to note here that is very helpful for us is that anything that is done by the BHO will be conducted through Internet Explorer because it loads it as a library. Next, we started to consider our method of operational persistence mechanism. So it's generally two primary modes that we have. One is passive, which is waiting to be triggered, and one is active. For passive mode, it could be useful, for example, for APT that wants to hack the planet. It has compromised multiple machines. Then it can put a persistent mechanism in these machines because it doesn't need them today. But 6 months later, 12 months later, perhaps triggered by geopolitical reasons or financial reasons, it could then require the need of this, and it can then activate them sometime down the road. For us, we are doing a short-term assessment, 3-month assessment, where we wanted to quickly be able to compromise the infrastructure. And secondly, we're also facing a few issues, as discussed earlier, in terms of persistence. So therefore, we went for the active approach, which was more suitable for us. Knowing the mechanism we need, we started to consider the features we need for the BHO. Earlier, as I was mentioning as well, the intention of the BHO is not to be a super tool. The intention for the BHO is meant for it to persist in the environment and thereafter able to load a fully featured payload if necessary to conduct any further attacks. So for us, we will need the BHO to be able to rewrite to file, to be able to write any potential payload, stop payloads that we want on the file system. We could also use it to exfiltrate data as well. We need to run command for obvious reasons. We need to run shellcode if our extended payload is a shellcode, then we can load it as a shellcode as well. And importantly, you need to support for different situations because the intention for this again is to use it as a stager to load something else. All right, So now we have the idea of what we want in the BHO. We started to think of how we actually implement it and develop it. Just to give introduction, a high-level introduction of how the active mode mechanism will work. So first, the Internet Explorer will actively poll for a server. In this case, let's call it xyz.com. So for us, in this case, xyz.com is not our C2 server. We have utilized this domain generation algorithm so that we can generate a list of domain that we will poll to obfuscate the defenders. Today it could be xyz.com, tomorrow it could be abc.com, so that defenders will not be able to easily find what is our actual C2 infrastructure. You also have a time aspect to it as well. So every 7 days, this list will refresh. So within these 7 days, if the defenders do find our C2 infrastructure and blacklist it, in 7 days' time, we will be able to continue the attack using the infrastructure on a different domain name that has not been whitelisted. So next time, it could be communicating to cnc.com, and cnc.com happens to be our C2 infrastructure. The cnc.com will come back with encrypted instructions. We have employed end-to-end encryption for this case. It's because for today, many corporations are employing SSL proxies. Essentially, what this means is that even though the transport layer could be encrypted using HTTPS, for example, the SSL proxy will be able to decrypt them and be able to view our instructions in plain. And this is not what we want. We want to make sure that our OPSEC is safe. We are able to send our instructions over without the defenders being able to know what we're trying to achieve. So BHO within Internet Explorer could easily decrypt it, and thereafter does all the different things it needs to do. So I'll go through it in detail. So step one, as I was saying earlier, you'll generate a domain using a pre-shared secret. So what happens is with the pre-shared secret, as well as the time aspect to it, it will generate a list of domain names, and within this list of domain names, it will randomly select one of them to try for every attempt it does. So once it decides at one of the times, depending on the ratio that you set, you will then be able to select the right C2 channel randomly at the right time. Next, there will be decryption of the encrypted instructions. So as long as the instruction is sent over to the BHO through the Internet Explorer, the BHO will then decrypt the instructions before executing them. And lastly, is execution of the instructions, sending them to whether they are running shellcode or running command. So one thing to note, and it was useful for us as well when it ran as a DLL, is that it's able to outsource different functions. In our case, we needed to execute shellcode. And executing shellcode is not a standard functionality in .NET. So what happened is we imported a few functions, virtual alloc, virtual free, as well as create thread from kernel 32 DLL. And using these functions, then we were able to execute shellcode by doing virtual alloc, rewrite, execute, and then thereafter creating thread on the shellcode. All right, we thought all was nice and sweet, but as with all fairy tales, there is always a villain. In our case, unfortunately, there is protected mode. So Internet Explorer 7, since Internet Explorer 7 has implemented protected mode, and the reason for this, I suspect at least, was that, well, Internet Explorer sucked big time. There were vulnerabilities pretty much every patch Tuesdays we were seeing vulnerabilities for Internet Explorer 6. So what Microsoft did was that, hey, there's so many bugs here. Let me just put a wrapper around it. If Internet Explorer is compromised, the wrapper kind of keeps it there so that it doesn't damage the rest of the system. For us, we had code execution. So we already had it, so we weren't trying to break that, but because we were using it as a BHO, as a persistent tool, it affected us. How it works, it's first, if you have seen this little checkbox, this basically activates the protected mode. And how it works, it puts Internet Explorer it protects Internet Explorer under protected mode using 3 different mechanisms. First one is user access control, Windows integrity mechanism, as well as UIPI. I won't go through this in depth. Just now, James did mention a little bit on UAC, but I won't go through this in depth. But what is important to note is Windows integrity mechanism specifically that is preventing us from achieving what we want. In short, too long don't read. our BHO will execute as a low integrity under protected mode. Just to give you a comparison, if you start the application using the start menu, you will start off as a medium integrity. So in Windows, everything is object, and low integrity object is not able to interact with medium integrity object and above. Pretty much most files in file systems are medium integrity, except for very selected directories. So what happens is it limits our ability to call API, it limits our ability to read-write to files. Pretty much most files that we want can't be read or written. And we are not able to extend our kernel 32, we are not able to import kernel 32, and we are not able to run commands. Essentially, everything we wanted to do can't be done. And guess what? No surprise. We'll be getting out of the protected mode. Well, I'll first go through how protected mode works for Internet Explorer. So Internet Explorer places sites into different zones and applies security based on the zones they are in. There is an internet zone, intranet zone, trusted sites, and restricted sites. Don't have to remember them, but just take a mental note of them. I think some other mechanisms basically traverse to trusted sites, for example, and that has the protected mode turned off. But I'll be doing something slightly different. What is not shown there is there is a mode called My Computer. That is not in the option as well. Sorry, it's a little bit small, but it's the zone right there says My Computer. So our goal is to not care about the 4 zones that is shown in the internet options. Is to go to a zone called My Computer, where protected mode is turned off. So in the internet zone, our BHO needs to get into the My Computer zone and executes what it needs to execute at there. I'll go through it slightly in more detail. So as a user is surfing google.com, for example, the protected mode is turned on. It's running at low integrity level. What happens in the same example is cnc.com sends an encrypted instruction over. The encrypted instruction gets decrypted. Now it's telling the BHO to escalate. What happens in escalation is that the BHO will tell Internet Explorer to navigate to, say, a picture, URI of picture !run shellcode. Internet Explorer will then see that, hey, this is a local file, it's safe. You will turn off protected mode, set integrity level to medium, and visit the site. Visit the local file. And thereafter, once it's at the local file, the BHO will then read the URI again and will be able to pass the instruction of run shellcode and thereafter run the shellcode in with a medium integrity level. Yep. So what this means is our BHO will run in every zone, in all 4 zones that we have shown, because we simply get out of the 4 zones, no matter what is the default setting, no matter what is the change setting, it doesn't matter, because we are getting out of them, and we will execute the in the medium level integrity. We are able to pass the commands using URI parameter and instruct the BHO to read the commands from the URI parameter. It's currently not perfect in the sense that it's not 100% silent because we are traversing from the internet zone to a file, but it allows us to traverse to medium process integrity and thereafter load a fully fledged payload thereafter, and then we can conduct further attacks from there. Essentially, you're left with a passive or active mechanism in a regularly utilized application. Of course, it depends on the environment you're targeting. In our case, it was very helpful because in our environment, they were using Internet Explorer as the main browser for most employees. You'll be able to blend in and abuse application whitelisting rules. In fact, it was very effective for the application whitelisting because Internet Explorer as an internet browser needs to be whitelisted. And we were able to execute in the current user context, and we were able to load a fully fledged payload from there on. So I'll go through 2 different demonstrations. So the first demonstration will be going to cover, to show us essentially getting out of the protected mode. All right, so our POC is essentially running Notepad. a very trivial application. And in the second example, later on, there will be escalation. So the encrypted string basically it's an encrypted instruction that you will conduct after escalation. So in this case, we would first try the example of going to the notepad, where it's a simple running of a command. So we have loaded the page, nothing happened. We want to make sure that the instruction is there. We find out that the instruction is there, but because we are in the internet zone, we are not able to run a command within this when our integrity level is at low. So as you can see, we are in internet zone, protector mode is turned on. As we try again now, well, Internet Explorer. In the second instruction, second payload, notepad runs. And this is because, as you can see from the background, we have traversed from an internet zone to an image. As you can see, file : //. So we have moved on to an image, and from there, the integrity level is integrity level is medium, and thereafter we are able to load Notepad and to launch Notepad. All right. Now in our second example, we will demonstrate that to demonstrate essentially what we wanted to do, to use the BHO as a persistent mechanism, and thereafter we were able to load a fully featured payload from there on. Just to note, this demonstration is using passive mode in the sense that we are directly running the command. Directly going to the POC command to have a more direct demonstration. All right. So Jane is happily surfing the internet, and she sees, oh, click here for money, or visit the site. So in the background, we have set a Cobalt Strike listener. So what happens as Jane clicks this, you can see it's actually POC escalate. So you can actually see the escalation, the actual command. We're running Cobalt Strike from a PowerShell. So thereafter, Jane clicks it. Nothing seems to have happened. She seemed to have, oh, it's weird, Internet Explorer doing its weird thing again. I'll just ignore it. And wow, what has happened is that actually Jane has clicked on the Cobalt Strike payload, and now we are able to, I'll pause it. Yeah, so now we are able to get a callback from the Cobalt Strike payload. So essentially, it features the full, or rather it features what we intended to do in the first place, to use it as a persistent mechanism. And once it's activated, we are able to get a callback and to load a fully featured payload onto. All right, so that's the demonstration, but we are not ending it from there. The purpose of Red Team is not to win the blue team and then says, yeah, we got it, see you guys next year, suckers. Well, that's not the point of Red Teams, though many of us feel like doing it sometimes. But the purpose of Red Team for us is to make the defense capabilities better, is to help our clients to build a better defense mechanism. So essentially, we have a detection component as well to essentially go through how we may detect potential malicious BHO. All right, just a small evasion that we have found out as we played around is that Windows sees internal auto runs, which is something that a lot of IR people would use as a first tool to identify things, persistence mechanism, is that you actually do not detect .NET BHO assemblies by default. It actually detects BHO if they are native DLL. So if I write it in C++, it loads it well. But if I load it as a .NET assembly, it does not detect it. And as you can see on the left, we have actually loaded the BHO agent. But on the right, it doesn't show on the sys internal auto runs at all. So one way to actually find out if there is malicious BHO is to directly enumerate it, like how Internet Explorer would do. So first, you go to the registry subkey for browser helper object, and we see, well, disease state beef, food. Maybe this is interesting. Then we take the CLS ID and we go to the classes root to find out where is the DLL path. And from the classes root, we are then able to find out DLL path and to verify if this DLL is whitelisted or installed by the IT department. If it's not, then you would warrant a deeper investigation. Of course, there are also other artifacts in its operations that may be detected. So first off, as I was mentioning, the installation. So as it insert new COM object, or if it writes to a BHO registry key, it could be detected. In the loading of a BHO, there will be loading of anomalous DLL library during Internet Explorer startup, and this could be detected as well by the blue team. There is also execution of code when there is a creation of child process by Internet Explorer, or there could be allocation of memory region with rewrite execute if you are loading it as a shell code. And lastly, in terms of C2 and exfiltration, there will be connection to uncategorized website, and there will be periodical beaconing as it loads. One thing to note, and it's a very important thing to note, is that many of these artifacts could be spoofed and could be bypassed. So for example, the creation of child process, we can easily spoof the parent process so that it does not get detected that Internet Explorer is spawning processes. For rewrite execute, we could use something like Gargoyle so that you only wake up when and set the memory region as executable when it needs to. And of course, for the uncategorized website, we could easily categorize them. It takes seconds or minutes as soon as we do a reverse proxy. Yep. One, perhaps even more important area to think of is that there are artifacts everywhere. So this is an entire attack that we are doing on an organization. It's not just a persistent tool. So I think it's important to take a swim bridge approach to defense, because I think many people are still focusing on whether you are being exploited and to prevent exploitation. But once they only focus there and not everything else, you'll miss out on many opportunities to perhaps find out that attacks happening and to prevent loss of resources. Yeah. So in conclusion, preventive controls exist. For our case, we saw that the EPP was preventing us from doing things from basically persisting. But essentially, they could be bypassed. We bypass the EPP, we bypass protector mode. For us, we have demonstrated a successful target attack simulation. So for us, we have successfully managed to persist, and from then on, we could continue the rest of our exercise. We have also went through the BHO designs and consideration. Hopefully, as I went through the decision making, it makes sense to you. If not, you could raise the question afterwards as well. And lastly, again, although it has been emphasized, can be emphasized more, but there are multiple opportunities in the queue chain. It's important for defenders to take an assume breach approach so that you are able to take full use of the opportunities to be able to find out if attack is happening or to be able to collect artifacts from different parts of your estate. All right, so that is all for the presentation. Any questions? All right, cool.
An image tag or as a resource?
Okay, so for that, we were not able to do that. So what happened is for Internet Explorer, it only moved to it moves to the medium integrity without protector mode if the main root document is actually the local file. And interestingly, behind the scene, actually, as we have observed, or briefly, what happens is it will spawn a new process with a medium integrity level and shift the state over to the new process on the medium integrity level, and then works from there on. So unfortunately, yeah, we're not able to just load a hidden view, for example. Yeah.
Thanks.
Yeah. But yeah, interesting. We actually tried that, but yeah, unfortunately, it didn't. Yeah. Right. Okay. Oh.
Sorry. So for this, is there any way of maintaining that persistence if the targets aren't using Internet Explorer, as in they're not daily using it, they're using other browsers?
So for that, then it really depends on our choices. So as earlier mentioned, because we have two goals. First, it's to be able to bypass the whitelisting, and secondly, to be able to connect back to our C2 server. So essentially, then we need to consider three different opportunities. The second opportunity for going through Microsoft Office would be very appealing if there is really no other applications that we need to use. Then we could make use of that, for example, to call back. Yeah. So essentially, there are actually many opportunities and many choices that we could have taken, but it really boils down to what works best in that environment that you are in.